because our last solution will equal to the y bar, and this y bar we're doing its equation, and this yx also include the 2 pi I of this, and here the residual will be what will be the minus 2 pi I, sorry, square root of 2 pi 2 pi I, and the residual is a p bar gamma 0 e minus gamma I gamma 0 x with gamma 0 plus omega c0. Okay. The residual of this one at this one is we select only this one. So we time this on here, and you cancel and put gamma to gamma. So that's why we have gamma 0 plus omega, and this is residual. All right. Okay. Yeah. Then so the yx, this one, and equal to minus pi I over square root 2 pi pi I, right? Yx minus sweet pi I, okay. Pi I over square root 2 pi p bar omega over c0 minus x I omega over c0x, right? And 2 omega over c0, right? So here I have 2 pi I, 2. So this 2 cancel. So that's why we have a square pi I, and this is omega over c0. Okay, so this is for this contour integration. And this one certainly will be 0, okay, later on, okay. And this value. But the key point is here. If you put this into here with I omega t, you will get so my yxt is equal to the real part of y y bar x, is that right? Not yx, sorry, suppose yx, not y bar x. Yx, okay. Yx, not y bar, okay. Yx exponential minus I omega t. All right. Yx, okay. So Yx, all right. And that will be minus pi I over square root 2 pi p bar omega C0 exponential here minus I omega x over C0 plus t. Okay? So this term will combine with the term here. All right? To form something like this. Okay? So this term will be have a sine omega minus sine omega x C0 plus t. And some cosine. Yeah. Something cosine, right? Plus I sine something. But anyway, so this term means the wave is propagating what? To the left, right? To the negative x direction for x positive. Okay? So that means when x at infinitive, your wave is coming from the it doesn't make sense, right? Because our wave is propagated to the positive direction. So this is a convolution. It's propagated to the left. It's an incoming wave. Incoming wave at x equal to positive infinity. So at positive x, that's incoming wave. Doesn't make sense. It's wrong. So we cannot choose this as a residual. We have to choose this one into our contour integration. Understand? Yeah. Right. So similar, doesn't matter x is positive or negative. If x is negative and we still have a plus and a minus sign here, so that would be plus. Sorry, if x is smaller than 0, we have to choose upper, but the residual doesn't matter x is positive or negative, right? So for this one, maybe it will change. Yeah. So okay. So for two residual, doesn't matter is x larger than 0 or smaller than, we'll always choose this contour. This contour. So we choose the second contour as lower, right? For x larger than 0, I have a contour contain this, exclude this, then infinity. Okay, so my contour like this. I contain this contour residual. So the residual will change to minus. Okay, let's see. If I change the contour, then the residual will 2 pi I, residual at this, minus, right? And, right, minus. So it's plus, plus, plus. Plus, okay? Plus. Sorry. Right, plus. No, no, plus. It's minus here. And this gamma minus is plus. Okay, and this is minus, right? The residual minus. So minus 2, right? Minus 2. And for x smaller than 0, for x smaller than 0, okay, so we leave here. So this, you combine with a minus, you will get minus x with t. Okay, then for the x smaller than 0, you will have a form like this. So this means the wave to the right, right? So at x equal to positive, that would be outgoing wave. So makes sense. Okay? So we keep on choose this as our wave, the residual. Okay? Understand? Yeah. Okay, so after this discussion, let's complete the integral. Yeah. Okay. So you can see, if I choose this point, the integration will have y xt equal to residual something exponential I omega x over c0 minus t. Okay, so we have this minus here. Doesn't matter it's positive or negative. If for the upper circle, the low one is like this, right? But for the upper one, just minus sign here, but still have this time. So this term shows the wave, this wave is outgoing at x equal to plus or minus infinity. Okay, outgoing. Now the incoming, both this point and point. Okay, outgoing. Okay. No, it should be positive. Yeah, outgoing. Yeah. Okay. Outgoing, yeah. Outgoing means from center to out. Incoming with both coming out. So this plus minus. It's okay, yeah. All right, yeah. Okay. So now we decide our contour for x larger than 0. We use this one. For x smaller than 0, we choose the contour like this. Here. That's my R. And the contour is here. Oh, sorry. Still containing, right? Should be containing this one and this one. And this one, not. Okay, and this one is contain this pole. Okay, and this is containing this pole. All smaller than this for x large, because here x can be larger than 0, x can be smaller than 0. For different x, when you input, you should choose different contour. Okay, the result will be a little bit different. Okay. Yeah, maybe this is the most, not difficult, most complicated mathematics you have made before. Oh, I think it's extreme, yeah. Mechanics is my experience. Because we do not use a complex variable integration quite often, but this is a real application, okay? When you learn the complex variable theory, you don't know why we learn this, right? The purpose of learning complex variable just for this kind of integration. Okay, the residual series. The purpose of learning residual series is just conduct this kind of singular integration. Okay, because in mechanics we always admit a lot of this kind of singular integration. Okay, especially when you do some Fourier transform or Laplace transform, when you come into inverse back, you have to use the residual theory. Okay? Some people say, oh, complex variable is 2D. Why? All problems 3D. The problem is we have an imaginary part and a real part in complex plane. Okay. All right. So let's do one example. Okay.